Here I have a Fisher-Price Dragon. Beautiful item, well at least I think so. I suppose beauty's in the eye of the beholder. If we have a look, yes, on its leg it says it's Fisher-Price, so I assume it is. And if we look at the circuit board, then we have this rather nice circuit board. Interesting design on it. I've disconnected it from the Dragon itself and put some 0.1 connectors on so I can easily connect to it to find out where my problems are. So here I have the connector to the switch which changes the direction. I've just plugged an LED in here, and we have the speaker up here which comes straight from the chip via this resistor here. We have capacitors, surprisingly to me, in series, but I assume the situation is if one goes short circuit, then the other one still protects the circuit. So it's sort of 4 drive transistors and 4 transistors to drive the drive transistors, and a transistor here to drive the LED. If we look at the circuit then, sort of bog standard sort of H-bridge circuit, sort of has 2 halves, the orange half and the blue half. Both shouldn't be on at the same time, else there will be a short circuit. If we look at one side, let's look at the orange side. The IC then sends a signal. The transistor is normally held off by this R19. Turning this transistor on connects the base of this transistor to a ground, thus switching it, since it's a PNP, switches it on, which switches on this PNP, thus providing positive to this side of the motor. This transistor also then supplies a current down into this transistor, this NPN transistor, which switches on because it goes high, normally held off by this R16, so that then connects this side of the motor to 0 volts and it goes one way. The blue circuit, just very similar, just the opposite. What I have here is 2 diodes. Interesting this, because it comes from these 2 drive transistors. If the transistors are off, then these resistors will supply a current to this point here, both from this side and from this side, so it's a sort of OR gate. If this transistor's high, if this point is high, then this will be high, or if this is low but this is high, this will still remain high. So I assume this is some sort of protection feature which sends a signal to the IC to check that both transistors aren't on at the same time, which could cause a fire, as it would directly connect positive to negative. The direction switch then goes straight from positive to the IC. I assume there's pull-up resistors inside the pull-down resistors, inside the IC, so that this would normally be low and only goes high when that's switched. If we look at the speaker then, no amplification on the speaker, just out from the IC through a resistor and then out to the speaker. If we look at the LEDs, the eyes, then we find that there is a drive transistor for these 2 LEDs, and each LED has its own protection resistor. If we look at the slide switch then, once again I assume it's got pull down resistors inside the IC, so that they're normally low until this is operated when it goes high or low. I only found this switch when I pulled it in bits because it's on the back and looks like part of the tail. So and it switches itself off. It's spring loaded, so it just switches itself off. The capacitors, as I say, we have 2 220s connected in series and 2 104s connected in series. Presumably if one goes short circuit, then the other one protects it and it doesn't short it out. If we look at the board itself then, we've got our 4 drive transistors driven by these 4 smaller transistors, the 2 capacitors and 2 capacitors, the output to the speaker, and the drive transistor to the LED through this protection resistor here. The diodes here, here, here and here are the protection diodes for the chip across these transistors. Right, so if we try it then, let's have a go, see what we can do. Switch it on, nothing happens. Move the switch, the LED lights, and after a period of time goes out. Switch it the other way and nothing happens. Similarly, nothing happens if I connect a speaker to it. Tried different speakers but nothing happens. Can test the output if I connect the output to a motor. So here we have a motor connected to the outputs, and I've disconnected the 2 drive resistors from the IC so that I can just put a positive voltage onto them to see what happens if the drive circuit is still working. Okay, connect a positive lead. I'll use the end of the diode, which is quite easy. Then I want to connect that onto the ends of the resistors, of course being careful not to connect them both, else I'd have a short circuit. Hopefully we can see that is going anti-clockwise, and the other resistor is turning that gear wheel clockwise, so the drive circuit's still working. Where to go from here? No idea. This circuit board is very clever, but it's very complex. We could just use one chip nowadays instead of all this lot. So I'll probably reconnect it, redesign it and put a simple delay on it so that I can play with it and amuse myself. I really like this dragon and really want to get it working.